Hey guys, so I wanted to go ahead and upload the rest of the review packet, and with the videos, I think that's probably all I'm going to give you at home, because to be honest, I'm thinking that's all you're going to do. And I think there's a chance if we go to school on Friday, they may or may not start exams. So but I feel like the review packet is definitely worth going over. So I'm going to go through the problems that I have marked as day 4 as a reminder. So I'm going to show you the question, then I'm going to work it out on my piece of paper. So this first one is problem number 4. It's a vector problem. So I'm going to sketch a little vector graph. Sorry, that's a previous problem. I'm going to sketch a little vector graph. So here's my vector graph, and it says that it's going south 15 miles an hour. So this is 15, and it's going east 5. So we're going to go 5 and 15. So my vector is going to be somewhere right here. And it wants to know not the magnitude, which would be the length of this, but it wants to know the direction. So we can use the fact that this point is at over 5. Is that right? Eastward 5, and south, which would be negative 15. We can use that to find the r, but we can also use it to find theta. So the theta, the tangent of theta is equal to y over x. Remember that formula from 5,000 years ago, it feels like. So so we get the tangent of theta is equal to a negative 3. Anyway, when you calculate that angle, you actually get 71.6, which you're going, oh, that's the right angle because it is 71.6. But in reality, we have to actually subtract that from 90, and we did a few of these, which gives us 18.4 degrees east of south. We did a couple of those, and it had something to do with the bearing and how you calculated the bearing, and then you had to subtract it. So that is that problem, and as a reminder, you do have to subtract. Okay, so the next problem we're going to do is problem number 11, which I sent you a video, which would have been super helpful. So problem number 11, we have to find the polar coordinates given that point, and they actually kind of mix things up a little bit because they don't want us just to find one polar coordinate, they want us to find multiple polar coordinates. Super fun. So we need to remember, let's get a clean sheet of paper. Hope everybody's enjoying all the snow today. Currently it is 5:30 and it is still snowing. 5:11, Eli says, sorry, and Eli says hello everyone. So this is problem number 11, and we know that r squared is equal to x squared plus y squared, and we also know that, again, the tangent of theta is equal to y over x, and we literally just did that. So so we are going to take our problem that we did. So we're going to do r squared, which we don't know, is going to be equal to x squared, which is negative 2 squared, it's a 3 squared, plus y squared, which is 2 squared, it's a 3 squared. And I'm not baking cookies this time, or brownies, so I hope that's okay. So when you multiply that out and then take the square root and simplify it, so you would square this and square this. So this would be 4 times 3, because negative 2 squared is 4, the square root of 3 squared is 3, plus 4 times 3, so 12 plus 12, so we get r squared is equal to 24. Of course, you take the square root of both sides, and we get r is equal to 24 breaks up into, in case you didn't figure it out, it was plus or minus 2 squared to 6. So if you were looking, all of those answers have plus and minus the 2 squared to 6. All right, so now it wants to know what the coordinates of the angle are. So so remember, we're going to use that tangent of y over x. So the tangent so it's going to be 2 square roots of 3 over negative 2 squared roots of 3, which is going to be negative 1. And we're going to find out where tangent is negative 1. So you are going to use your unit circle and find out that tangent is a negative 1 at 135 and 315. You could also do that. Using your calculator. You could just put in inverse tangent, so second tangent, and get that. So I probably should write down the tangent, the inverse tangent. So that answer choice then for number 11 is B. If you missed number 4, the answer choice was D. All right, moving on. Number 12, which equation in the rectangular form of the polar coordinate is that? I hope you have these papers at the ready. Which equation is right? And I'm going to do this one and then I'm going to pause it so hopefully the upload will go a little faster. So let me get my cheat sheet out. I worked all these problems out. I was just going to post these for you guys, but a couple of you could have muddled through my work, but I wasn't sure anybody really would want to. So, and you'll notice from my chicken scratch that pretty much it's the same kind of problem that we did before. You'll also notice right there in the middle that I tried a couple things and it didn't work out. So the idea is that we have to get that formula changed over into something that's got either r times cosine or r times sine. So because that is x or y. So we start off with this. And we did some of this in class. I don't know that we spent a lot of time doing this. So this is a good review or a good refresher or a good idea. So the first thing I tried was just squaring or multiplying both sides by r. But that did not give me what I needed. So then I thought, I wonder if I could cross multiply, because that will give me my r with my cosine. So I cross multiply, which is an understood 1. So I get r times 1 plus cosine of theta is equal to 2. And so I'm going to multiply that out. R plus r cosine theta is equal to 2. We know that r cosine theta is actually x. So we get r plus x is equal to 2. Let me double check to make sure that I got that right. Is r cosine theta x? Yes, it is. So we are then going to make r by itself. So I'm going to move this over. So 2 minus x. Now, I am going to rewrite this side of the equation, replacing, I'm going to square both sides. So I'm going to square the whole thing. So I get r squared is equal to 2 minus x squared. R squared is equal to 4. Minus... Let's see, minus 4x plus x squared. We know that r squared is equal to x squared plus y squared from our previously stated problem. If you know 2 things about polar to rectangular coordinates, you need to remember that r squared is equal to x squared plus y squared. And you need to remember that tangent of theta is equal to y over x. So just in case you had forgotten those. And to be honest, I looked them back up. Again, so, and the tangent of theta, which is the angle in between that, is equal to y over x. Now, yeah, so x squared plus y squared is going to be equal to this. We're going to simplify both sides, which means I get rid of this and I get rid of this. And if you start looking at your answer choices, you can start to see that several of the answer choices are going to go away, because you are going to be able to solve it down to answer choice C, which is going to be y squared plus 4x. I'm going to move the 4x. Y squared plus 4x equals 4, which is answer choice, sorry, not D, C. Now, as a reminder, if you had done this the opposite way, where you said r cosine theta was y instead of x, you wouldn't, that answer choice is there too. So make sure that you know the difference. R cosine of theta is x, just like it is on the unit circle, and r sine theta is y. Okay, I'm going to stop the video to make load up easier, and then I'll pick back up with the next problem, which is problem number 13. Yay!